Today we're at the Cereza Passive House on Concrete Day, and specifically we're talking about concrete strength and slump tests. Let's take it away. California is earthquake country. In an earthquake country, everything has to be designed to withstand the loads placed upon it by earthquakes. And that foundation is where all of that load from above on the house and on the walls and on the roof go down and is anchored into the ground. When the earth shifts, it drags the foundation with it, which means everything above it has to be strong enough to withstand that earthquake. Today, we're looking at concrete testing. This is a concrete cylinder. We're going to be doing two tests with this cylinder. The first is called a slump test. Now, concrete is an interesting material in that water is the main component that makes concrete a good binder. But unfortunately, too much water makes concrete weak. So we have to make sure that we're adding just enough water to get maximum strength from that concrete, but not too much to reduce the strength of the concrete. Because if we reduce the strength of the concrete, all the calculations from the engineer are really not accurate because the concrete is not doing its part. So what we need to do is do a slump test. Now the slump test, we take this cylinder and we fill it with concrete. Then we turn it upside down on a piece of plywood and we lift it up, obviously without the lid. We lift it up and then that concrete cylinder drops. And the amount that it drops is called our slump number. The less that concrete drops or settles, the stronger our concrete is. Now, it has to be done at a specific time because as we know, the longer concrete sits, the stiffer it is. So the concrete comes off of the truck, we put it in this cylinder, we flip it upside down, and then we pull the cylinder up. The lower the slump, the stronger the concrete. Next, we're gonna take another cylinder of that concrete, we're gonna fill it up, and we're going to put a cap on it, and we're gonna set it aside for 28 days. At the end of 28 days, called its 28-day strength, we're going to put this in a giant machine. We're gonna take the concrete out of it, we're gonna put it in a giant press, and then we're gonna look at how strong that press has to push before that concrete cylinder breaks apart. That's called its strength testing. The concrete for this basement has to be 3,500 PSI, which means that 3,500 pounds per square inch of force has to be applied to this concrete before it breaks. If it breaks before that 3,500 PSI, that's really bad. And the structural engineer then has to determine how we add additional strength into that foundation element so that we can make sure that that house is strong enough or that foundation is strong enough to withstand all the forces that an earthquake would put on it. Lastly, we use a mix called 70% fly ash. And fly ash is actually a combination of fly ash and coal slag. Fly ash is a byproduct of the coal-fired power plants, and it's normally a waste product that has to go into landfills. We use it to offset the amount of cement in our concrete samples. We also use coal slag, and coal slag is what comes from the steel smelting process. And that slag is also a waste product from steel smelting that we can use to offset the concrete or the cement in concrete. Both of those products result in a much stronger concrete, but it takes longer for that concrete to get to its full strength. So normal concrete gets to its full strength in 28 days. Our 70% replacement takes 56 days to get to full strength. So even though we size the concrete or we determine the concrete straight at 28 days at 3,500 PSI or 4,000 PSI, all concrete continues to get stronger till 56 days. So even though we're required to do a 3,000 or 3,500 or 4,000 PSI mix, when this house gets done, the concrete's gonna be closer to 5,000 or 5,600 PSI, meaning this house will be more than strong enough to withstand the strongest earthquakes in this house, while also, because we're using fly ash and coal slag, we've reduced the amount of cement. And cement is the single largest contributor to global warming gases of any material used in the world. And by using 70% less cement, And using waste products, we're dramatically reducing the environmental impact of concrete, or of this concrete and this house on the planet. If you're interested in learning more about building science or about the Syriza Passive House, click subscribe as we show you how to build a better way.